Hi dear students, I hope you all are doing great. Today we are going to discuss about some of the important numericals from Cbse grade 10, which is related to your application based or they are the competency based questions, and I believe that you will be practicing it and writing everything down so that your concepts are also clear. Understanding the first question, that is a current of 2 ampere flows through a resistor of 5 ohm. Calculate the potential difference across the resistor. Now, if you see in this question, first and foremost thing which is very important is that you need to write what is given. So what is given in this question? Current, which is 2 ampere. What is the resistance here? It is 5 ohm. And the formula, which we all know is that is V is equal to I into R. Now, when you substitute as V is the voltage, I is the current, R is the resistance. So you get what? 2 into 5, which is 10 volt. Clear to you? Let's understand question number 2. A potential difference of 12 volt is applied across a resistor and a current of 0.5 ampere flows through it. Find the resistance. Now again, what we have to find? Resistance. What is given? Voltage, which is 12, and then current, it is 0.5 ampere. What is the formula? As we know, the formula is V is equal to IR. I'll quickly jot it down. But here, what has been asked? We have asked resistance. So resistance will be the subject and it becomes V upon I. So after substituting 12 upon 0.5, you get resistance as 24 ohm. Question number 3. A wire has a resistance of 20 ohm if its length is doubled while its cross-sectional area remains unchanged. What will be its new resistance? Now let's see how to solve this question. First thing, you need to write what is given. Now what is given in the question? Original resistance, which is 20 ohm. Now, if its length is doubled while its cross-sectional area remains unchanged, so we have to find the new resistance. So for the same material and the same cross-sectional area, which formula do we use? That is, resistance is directly proportional to length. Now, if the length is doubled, so what we are going to do here, the resistance will be double. That is 2 into 20, and your answer will be 40 ohm. Question number 4. Two resistors of 4 ohm and 6 ohm are connected in series with a 20 volt battery. Here you need to find the equivalent resistance. You need to find the current through the circuit and the potential difference across each resistor. Now, the formula which you need to remember for the resistance in series, that means all the resistors are added. First thing, write what is given. So how many resistors are mentioned here? We have R1, that is 4 ohm. We have R2 as 6 ohm. So when we add it, we get as 10 ohm. Further, we have to find the current. Now, how are we going to find the current? Student, please remember, we need to understand the formula, that is Ohm's law. V is equal to IR. Okay, so current will be what? V upon R. So R goes here. So it becomes V upon R. So 20 upon 10 will give you 2 ohm, 2 ampere. Next is the potential difference. Now, how to find the potential difference? Across each resistor. Please remember, when we talk about across each resistor, we need to take one resistor at a time. So IR1, that means current was 2. And what is the resistor mentioned there? It's 4 ohm. So 2 into 4, that is 8 volt. What about the second one? It is 6 ohm, which will be multiplied with the current because current remains same. So 2 into 6 is equal to 12 volts. I hope this question is clear to you. Next is question number 5. Two resistors of 6 ohm and 3 ohm are connected in parallel across a 12 volt battery. Find the equivalent resistance. You need to find the total current and current through each resistor. You can pause the video because this question is very much similar to the previous one and I'm sure you have understood how to solve. So likewise, you have to take resistors in parallel. Earlier it was resistors in series. write down what is given. R1 is 6 ohm, R2 is 3 ohm, and what is given? Voltage is 12 volt. Equivalent resistance. Now this time the formula which you are going to use is it's 1 upon R. 1 upon R1 plus 1 upon R2, and when you do the calculation you get 1 upon R is equal to half, and resistance will be 2 ohm. Kids, how do we got this 2 ohm? Please remember it is 1 upon R is equal to 1 upon 2, and when you cross multiply, okay, so you get R is equal to 2 ohm. I hope this is clear. Now we need to find the total current. For the total current, again we are going to use the Ohm's law. So I is equal to V upon R, that is 12 upon 2, which is 6 ampere. Now here the current through each resistor, which we even term it as like a branch currents. So you have to take I1, which is 12 upon 6, that is 2 ampere, and I2, 12 upon 3, which is 4 ampere. And if you want to check it, it is I1 plus I2 will give you 6 ampere. Question number 6. Now here if you see an electric bulb is rated 220 volt and 100 watt. You need to calculate current drawn by the bulb and resistance of its filament. First write what is given. Now what is given in the question, students? That is 220 volts, and the power is mentioned. It is 100 watt. So current will be, we need to find it out. That is P is equal to V into I. Now these are some of the power equations, and I becomes the subject. So P upon V. So what is mentioned here? Power is 100 watt divided by 220, which will give you approximately 0.455 ampere. Next is we have to find the resistance of its filament. So R is equal to V square upon P, which is again the power equation. And when you substitute, you get 484 ohm. So this is the answer on the screen. Let's see question number 7. A student observes that a 100 watt bulb and a 60 watt bulb, both rated at 220 volt, are connected in parallel to the household supply. Now the question is that you need to find which bulb draws greater current. You need to calculate the current drawn by each bulb, and then you have to calculate the resistance of each bulb. And then one question is that why are household appliances connected in parallel rather than series? So first thing what you have to do, students, you need to write what is given. Now, if you see the first part that we need to find out that which bulb draws greater current, so you need to calculate current, which is P upon V. So here you get that is 100 watt bulb draws greater current. Next is that calculate the current drawn by each bulb. So you have to take I1, which is 100 upon 20, which will give you 0.455 ampere. For current 2, you get 60 upon 220, which is 0.273 ampere. So here you need to just substitute the value in the formula. Next, you need to find the resistance. Again using the power equation, so we get R1 V square upon P1. Substituting the value, you will get 484 ohm. Likewise for resistance number 2, we need to substitute the value and you get the answer as 7 ohm. Now the question is that why are household appliances connected in parallel rather than series? Now here if we see, they are connected in parallel so that they receives the same voltage and they can operate independently. And even if you switch off, it doesn't affect the other appliances. Students, let's understand question number 8 here. An electrical appliance draws 5 ampere current from a 220 volt supply. Two wires are available here. We have wire A and we have wire B. Now the wire is used to connect the appliance to the supply. For point A, the question number A, calculate the power lost. In Question number B, you need to find which wire is suitable and then why a wire with a lower resistance is preferred for carrying large currents. So first thing you need to remember, write what is given. So what is given here? Wire A, which is resistance is 0.8 ohm. Wire B, resistance is 0.2 ohm. And the power equation which we have to use for question number A, that is P is equal to I square R. For wire A, you just have to substitute the value, you will get 20 watt. For wire B, when you are substituting the equation which is given here, you have to substitute the value, you get 5 watt. Now the next question is which wire is more suitable? Definitely which has 5 watt. That means the power is less, so it will be more suitable. But why a wire with a lower resistance is preferred? Because it causes less power loss and less heating for the same current. Students, let's understand question number 9. A 5 ohm resistor is connected to a 10 volt battery. You need to calculate the current through the resistor. You need to calculate the power dissipated, calculate the heat produced in 5 minutes. And if the resistance is doubled while the voltage remains constant, what will happen to the power? And you need to calculate the new power. So what is given here? Resistance, which is 5 ohm. Voltage is 10 volt and time 5 minutes. Now for here you need to remember, you need to convert minutes into seconds. So 5 minutes will give you 300 seconds. First part, current is equal to V upon R. So what is the voltage here? 10 divided by resistance, which is 5, that is 2 ampere. Don't forget the Ohm's law. B part, you need to calculate the power dissipated. Here again, students, I'm repeating that you need to understand the power equation. So P is equal to V into I will give you 10 into 2, which is 20 watt. Calculate the heat produced. Now heat energy, power into time. So what is the power here? 20. And what is the time which you calculated in seconds? That is 20 into 300 will give you 6,000 joules. What will be the new resistance? Now here the new resistance will be 10 ohm. At constant voltage, if we talk about, that is your new power, which will be V square upon R dash. So here V square, that is the voltage mentioned, that is 10. So 10 into 10, that is 100 upon 10 will give you 10 watt. So therefore, if you have noticed here, the power becomes half. So thank you so much, students, and hope you have understood the concept of solving these numericals related to electricity. So next video will be on the formulas and board exam tips. So like, share, and subscribe for more videos coming soon. Thank you and take care.